Welcome. In this video lecture, we are going to study about integration of absolute value functions. Many students have been asking about integration of such functions, like we have in the example 1. So get tuned, and at the end of this one, we'll be able to do integration of any given absolute value function. So as a startup example, evaluate the integral from -2 to 1 of the absolute value of x with respect to x. This is what you need to remember when you are carrying out absolute value integration. Just remember that an absolute value function is defined by two formulas: x if x is greater than or equals to 0, and negative x if x is less than 0. From this definition, you'll be able to carry out the integration of the absolute value function. These are the steps to need to follow. You remember from the definition, absolute value of x is given by these two formulas with these given conditions. So what you do, you break the absolute value function given into these two formulas. With respect to each of the two formulas, you redefine the intervals of integration, as we are going to see in these examples here. So for this case, we have to integrate from -2 to 1. And then remember, by definition here, the reference value in the definition of the absolute value function is 0. So we have a 0 here. So from -2 to 0, we have the function defined, -2 to 0, this will be defined by this lower function. So will be negative x, and then from 0 to 1 will be defined by the first formula, x. So therefore, now you rewrite the integral as -2 to 1 of absolute value of x with respect to x will be given by from -2 to 0. Now, the formula which defines this limits from -2 to 0 will be the negative x, and then plus from 0 to 1, and the formula which defines this interval will be x, and then the x. So when you integrate this one, you get negative x squared over 2, and then limits from -2 to 0, plus integration of x is x squared over 2, limits from 0 to 1. Now, when you put in the limits, we'll get -0 squared over 2 minus 2 square over 2 plus 1 square over 2 minus 0 square over 2. So the first one, this would be 0, so minus, we'll have that -2, and then plus this one, we get a half. So remember, this so this minus this one gives us now -2, because there's a minus sign, then this minus from the definition. So we'll have 2 plus a half, which will give us 5 over 2. If you can as well draw a diagram to illustrate this function from the limits given, or you draw, or this how you can actually see this. This is x, so 0, -1, -2, 1, 2, 3, 1, 2, 3, -1, -2. So the value of absolute value of x from -2 to 2. So when x is -2, then we'll have the absolute value of -2 will be 2. When x is -1, the absolute value of -1 is 1. 0 is 0. So we'll have this and then 1, we'll have this point here. So that when you complete this one, and then you complete this one here, so this is the region of interest. So you see, if you call this one A1, we call this one A2. A1, this is the shape of our triangle. So it will be simply a half. Base of this triangle is 2 units. Height of this triangle is 2 units. So this is 1, this is 1. So you get 2 units. And then area 2 would be a half times base is 1 unit. Height here is 1 unit. So you get a half unit. So the total area will be given by area 1 plus area 2. So it should be 2 plus a half to give us the same answer, 5/2 units, square units. Square units. So that's how you can as well draw the diagram, and then from the diagram you find the area under the curve with respect to the x-axis. Example 2, integral from 0 to 5 of absolute value of 3 minus x dx. So just remember from definition that we have 3 minus x would be given by 3 minus x the way it is if this value is greater than 0 or equals to 0, and negative of the same thing if 3 minus x is strictly less than 0. So you can simply work out with the first formula to see the intervals where x should be falling. So you have 3 minus x greater than or equals to 0. So 3 greater than or equals to x. So this tells us that x must be less than or equals to 3. So which tells us that now the way the function is, so we have 0 to 5. So there's a point here 3. So from 0 to 3, then the function will be defined by 3 minus x. But then from 3 to 5, it will be the negative of the same function, 3 minus x. So therefore, you rewrite the formula. So you write integral from 0 to 5 of absolute value of 3 minus x dx will be given by integral from 0 to 3. Now, when it is 0 to 3, we define by the function 3 minus x, now without the absolute value function, and then plus from 3 to 5, it is the negative of the same function. So we have negative 3 minus x dx. Now, this one gives us 3x minus x squared over 2. You apply limits from 0 to 3 plus negative of 3x minus x squared over 2. You also apply limits from 3 to 5. Now, when you work out, the first value will give us 9 minus 9 over 2 minus 0, because everything will be 0 here, plus 15 plus 25. 5 squared is 25. So 25 over 2 minus 15, and then minus 9 over 2 minus 9. So when you work out this one, you get 13 over 2. Example 3, integral from negative 2 to 3 of absolute value of x power 3 dx. So also here, you say that absolute value of this one will be given by two formulas: x power 3 if x power 3 is greater than or equals to 0, and negative x power 3 if x power 3 is less than 0. Just from the word go on the definition of absolute value function. So we see that now we have from -2 to 3, and then we have another number 0 here. So from -2 to 0, because this will be values less than 0, so will be defined by -x cubed, and then 0 to 3 will be defined by x cubed. So therefore you write integral from -2 to 3 of x cubed dx will be given by integral from -2 to 0, and then the function here will be -x cubed dx plus integral from now 0 to 3 of x cubed dx. So this will be -x power 4 over 4 from -2 to 0 plus x power 4 over 4 from 0 to 3. So this will give us upper limit will be 0 minus -2 power 4, so minus over 4 plus 3 power 4 over 4 minus 0 cubed over 4. So in the first case, we'll get, so our 2 raised minus 2 raised power 4 will give us this plus, so it will give us 16 over 4, which is just 4, plus 3 raised power 4 is 81, and then over 4. So 81 over 4 81 over 4 plus 4 gives us 97 over 4. So which will be 97 over 4. Another example, example 3, if we have integral from 0 to 3 of x squared minus 1 dx. So the first thing you just ask from the definition, x squared minus 1 absolute will be given by x squared minus 1. The way it is, if the same value is greater than or equals to 0, and it's negative if x squared minus 1 is less than 0. So when you work out x squared minus 1 greater than or equals to 0, you see that x squared greater than or equals to 1. So x greater than or equals to 1. So therefore, this interval from 0 to 3, we have a point here 1 that will help us to know where whether in this interval 0 to 1 or 1 to 3, which function must be satisfied. So x greater than or equals to 1. So this will be the point here. So therefore, this interval will be x1 minus 1. This will be -x squared minus 1. So therefore, you say integral from from 0 to 3 of absolute of x squared minus 1 dx will be the integral from 0 to 1 of now -x squared minus 1 dx plus 1 to 3 of x squared minus 1 dx. So when you work out this one, you get -x power 3 over 2 plus x, and then you apply the limits 0 to 1 plus x power 3 over, so this is over 3 minus x, then you apply limits from 1 to 3. So when you work out this one, you get So when you put 1 here, you get now negative 1/3 plus 1, because this lower one will be 0, and then plus, so 3 cubed over 3 is 9, minus 3, and then minus a third minus 1. So this will give us 2/3 plus 6 minus, so here we'll get now plus 2/3. So 2/3 plus 2/3, 4/3. So 4/3 plus 6. Gives us 22/3. So therefore the answer becomes 22/3. And then last example on this one, integral from second last example, 0 to pi, absolute value of cos x dx. So when you do the same thing, you see that between 0 to pi, we have pi/2. So we'll have this integral will be given by integral from the integral from 0 to pi/2 of cos of x dx plus integral from pi/2 to pi of minus cos of x dx. Just use the same analysis. So this will give us sin x from 0 to pi/2 plus minus sin x from pi/2 to pi. So when you work out, you get this will be 1 minus 0 plus minus 1 minus 0. So this will give you 2. So the answer becomes 2. And then another example on the same, integral from 0 to 5 of x squared minus 4x plus 3 dx. So here you need to do some factorization. Remember, from the word go, absolute value of x squared minus 4x plus 3 will be given by two formulas, x squared minus 4x plus 3 if x squared minus 4x plus 3 is greater than or equals to 0, and negative of the same function if x squared minus 4x plus 3 is less than 0. So then now let's see, x squared minus 4x plus 3 greater than or equals to 0. To see which limits will this first formula apply. So you see that these are quadratic expressions. So product is 3, sum is minus 4, numbers -1, -3. So this can be written as x squared minus x minus 3x plus 3 greater than or equals to 0. So x into x minus 1 minus 3 into x minus 1 greater than or equals to 0. So x minus 3, x minus 1 greater than or equals to 0. I have to be careful here. So this one means x minus 3 greater than or equals to 0, x minus 1 greater than or equals to 0. So this, from this one you get 1, from this one you get 3. So therefore now you come and write, we have from 0 to 5. So we have numbers 1 and we have numbers 3. So this now 1 and 3 help us to partition this interval from 0 to 5 to know we need now to rewrite our integration. So we have 3 parts. We have part 1, this A, this B, and then this C. So from just this equation here, x minus 1, x minus 3, x minus 1 greater than or equals to 0. This is the one that will be defining the first formula. So from 0 to 1, pick a number like, say, a half. So when you put a half here, you get a negative value. When you put a half here, you get a negative value. Negative gives you positive. So which means that then, let me just label this one. So if I label this one, this to be formula 1, this one to be formula 2. So a half, so from 0 to 1, anything I pick from 0 to 1, when I put here, I'll get this value to be greater than or greater than 0. So therefore, 0 to 1 will be defined by formula 1. In this interval here, pick a number like 2. So if I put here 2, I get a negative, 2, I get a positive. Negative times a positive, I get negative. So it will not satisfy this condition. So therefore, this interval from 1 to 3 cannot be used for formula 1 because it doesn't satisfy this this condition here. So therefore, from 1 to 3 must be the function that defines that interval is formula 2. And then 3 to 5, pick a value like 4. So 4 minus 3 is positive, 4 minus 1 is positive. Positive is positive. So that's true. So therefore, this also from 3 to 5 will be defined by formula 1. So therefore, now you rewrite your integral now as integral from 0 to 5 of absolute value of x squared minus 4x plus 3 dx will be given by from 0 to 1. Now 0 to 1 is defined by formula x squared minus 4x plus 3, and then plus from 1 to 3 is defined by the negative of the formula, so negative x squared minus 4x plus 3, and then plus from 3 to 5 satisfy the first formula. So we have x squared minus 4x plus 3 dx. Now when you carry out the normal integration now to these functions which do not have absolute value functions, we get a third x power 3 minus 2x squared plus 3x. So we apply limits from 0 to 1 minus a third x cubed minus 2x squared plus 3x. We apply from 1 to 3. Remember, we're putting this negative because we are from the second integral was defined by formula 2. And then plus the last one, we have a third x cubed minus 2x squared plus 3x. We apply the limits from 3 to 5. Now, when you work out, the first one will give us a third minus 2 plus 3, and then minus 0 because now everything has an x, and then minus 9 minus 18 plus 9, then minus plus, so plus a third minus 2 plus 3, and then this last one plus 125 over 3 minus 50 plus 15 minus 9 minus 18 plus 9. So when you work out everything, you get 28 over 3. So this is how we carry out integration of absolute value functions. Just remember from the definition that absolute value of x is given by two formulas: x if x is greater than or equals to 0, and negative x if x is less than 0. So whichever absolute value function is given, put it in this form. So replace where there's x by that formula the way it is, and then work out to see how the limits are partitioned to see where you are, whether you can apply the formula in the first case or in the second case. So thank you, and if you have any question, please don't hesitate to ask, and then kindly subscribe.